In this video, we are going to search a code repository in natural language, which is quite interesting. So we can obviously do keyword search or pattern search using tools like grep, but that's not what we want to do. Okay. For example, here we have a code repository. It's this OpenAI Python code repository. Now it has multiple folders and subfolders and many Python files with this extension .py, right? And each file can have multiple functions. Now we want to be able to query this a repository in natural language. For example, so here we are going to write a search functions function. Now we want to give the text in natural language, like for example, hey, give me 3 functions which are doing completion API tests. Okay, so this is not this completions API test. These are not the keywords used in the function, or we don't have those in the comment section also. Okay, and then here is another example. Hey, again, give me 3 functions which are doing fine-tuning input data validation logic. And one more example, here we have command line interface for fine tuning. Okay, so we are asking for only one function. So as I mentioned, we don't have these keywords as part of the function. Okay, neither in the description nor anywhere. Okay, all right, let's see how we do that. So as I mentioned, here we have a code repository. I downloaded and put it on my desktop, but this can be any library, any Python library or repository, right? So you can straight away use this code on your own code repository. By the way, all this code is coming from OpenAI cookbook. I have not written this code myself. All right. So what we are going to do is, first, we are going to read all the Python files and we are going to parse those Python files to find out all the functions. And from each function, we will be extracting these 3 variables. Okay, the function definition itself. So that's the entire code of that each function, and then the function name and the file path. Okay, so we want to first parse all the .py Python files and build a data frame with these 3 columns. That's step number 1. And then in step number 2, we are going to build, or we are going to compute embeddings for the code. Okay, we are going to compute embeddings for the code using OpenAI. And then finally in step number 3, we will have our search query. And for this query, we will create embeddings and then we'll do some semantic similar search and things like that. Okay, we'll compute the cosine similarity and we'll return the top n functions which have the highest cosine similarity. That's what we are going to do. But let's start with step number 1, which is finding out and reading all the Python files and building a data frame with these 3 columns. Okay, so let's do that. So imported the standard OS, glob and pandas libraries. And then, so as I mentioned, I put the repository on my desktop and the repository or the folder name is OpenAI-Python. Okay, so this can be anything. Now then, we want to walk through all the files within this folder to find out the files which have .py extension. Okay, so we are using OS walk for that. And then the total number of Python files in this repo is 57, right? And then each Python file can have multiple functions. Okay, so we want to find out the functions, extract their names, etc. Now this is just a check. In case if the number of files written is 0, that probably means either this path or the folder name is given incorrectly. Okay, and then so here we found out all the files, right? 57 files. And then we are going over each file once at a time, and from each file we are extracting the functions. Okay, the functions meaning the functions and their code. Okay, that's what this function get functions is doing. Now before we go to get functions, now we know here are two examples of Python functions, right? Now the Python function name is this, right? For this function it is get function name. For this function it is get until no space. Okay, so we have a pattern to extract the function name. So in order to extract the function name, once a function definition is given, for example, let's take this is our function definition. Somehow we find out the function within the file, and then we want to be able to extract the function name. So we pass all this code to this function. Okay, and then we are making sure that this function is actually starting with def, because each function needs to start with def in Python, right? If it is so, then we are extracting the characters which are after def space. So we are excluding def space, meaning we are starting with G, and then until we have the left parenthesis, which is this. So given this code, this piece of code, for example, or it can be any function, to this get function name function, it will return the function name. Okay, so that's good. So given a function, we are able to extract the function name, and because we know which file we are parsing, we already know the file path. So next we need to extract the total function code. Okay, which we have already passed to this function, but we haven't looked at how we extract the function definition itself. Okay, so we'll see that now. Now get until no space. Okay, what this function does is, so here we'll give the full file code. Okay, so each Python file code will give it, and then what it does is, starting with the function line, function definition line. Okay, so for example, maybe let me see. It's a little tricky, but let me explain. Now, okay, so here we are calling this get functions, right? So let's start with get function then. Let's have a look at get function. So here we have provided the file path. Okay, so we read the whole code of a given Python file, right? And then we are splitting the file, we are splitting the code with /n. So right, each new line. And then what we are doing is, we are checking if a line start with def. If a line start with def, that means it's a function, right? So we take all the lines of that file, and then the line number where the def has started. Okay, so the I is the line number. So we are passing these two arguments to this get until no space function. Okay, so all lines, this contain the content of the Python file split by new line, and then I is the line number where the function has started, which we have already found from this check. Okay, so what we do next is, so we take the first line because that is the function definition line, and then we want to be able to find out where the function is ending. Okay, now whenever we have a function in Python, from the second line we know these are tab separated, right? Tab or empty space separated. Okay, and we might have empty lines as well. When the function ends, when we have a new line starting like this, right? For example, here we might have x is equal to 10. So this means this function has ended at this line. Okay, so from the second line, the function can have only specific character, right? For example, if we have an empty line, so what we are doing is from that line onwards, so we are assuming each function, it will not be more than 10,000 lines, but I mean, this can be any arbitrary, very large number. So from the next line onwards, we are checking if the number of characters in the line is equal to 0, meaning this function may have empty line. Okay, that's allowed. Or the first character, see here, we have the first character. So this is the line number, this is the first character. Or if the first character of the line is either empty space or a tab, as we can see here, these lines have a tab at their beginning, or we can even have this closing parenthesis. Okay, so if a line has any of these characters, that means the line actually belongs to the function, and the function definition has not ended yet. Okay. Now, if it does not satisfy any of these 4 criteria, for example, like here, that means the function has ended. So we are breaking it. Okay. It's a little tricky, but all we are doing is we are giving the content of the file separated by /n, and then we are giving the line number where the function is starting. Okay, so let's assume this is our whole Python file content, right? So the all lines contain all these lines separated by /n, and then we are giving I as the line number where the Python function is starting. For example, let's say this is our line number or whatever it is, let's say 15. So this function is taking all this code and this number 15. So starting with this line, what it is doing is, for each line, it is checking if the number of characters in that line is either 0, or if the starting character of that line is either empty space or a tab or closed parenthesis. If it is any of these, that means that line belongs to the function. If it is not any of these 4, like here, the function definition has ended and something else has started. That something else could be some variable declaration, or it could be a comment line, or it could be another function itself, right? So that's how we are able to get the definition of the function using it. Okay. All right. So every time we find this def space, that means we have a function there, and using this, we are getting the definition of the function, which is the function code. And then using this function, we are getting the function name. Okay. So here we are preparing, or we are creating a dictionary with the code, the function name, and file path, the 3 variables which we wanted here. Okay. So we'll loop over this, and for a given file, we are extracting all the functions, their names, and file path will not change for a given file, right? So that's what we have extracted. And we have done that for, we are doing that for each file. Okay. And then to this all functions, we are appending these 3 variables we have extracted. Okay. And then the length of the all functions will give us the number of functions our code repository has. Okay. So our code repository has 108 functions. I'll quickly summarize what we are doing here. We are simply finding out all the Python files, and we are going over the Python files one at a time. And from each file, we are finding out if there are lines which start with def. If it is so, then we are checking the lines followed by def. If they satisfy these 4 criteria, if they do, that means that line is part of that function. Otherwise, that function has definition has ended. So we are extracting the function definition, and here we are extracting the function name. Okay. And then we have extracted these 3 columns of data. And then here we are simply creating a data frame. Okay. Once we created the data frame, now comes the OpenAI part, right? What we have done until so far, it's a generic Python thing, right? So here we are using OpenAI utilities to get this function, get embeddings. Okay. Now we are going over the code part of this data frame line by line or record by record using this lambda function, and then we are getting the embeddings, or we are computing the embeddings using text embeddings ADA 0 version 2 model. Okay, so using this lambda function, we are passing each function definition one at a time and then computing the corresponding embeddings. Okay, and these embeddings we are writing back to the data frame as code embeddings, which is what we have done here. Okay, all right. And then from the file path, so this file path also contain the root, right? The root directory. We have just excluded the root, otherwise it would be this full user my name with a desktop, right? So it's a simple string edit. We are just writing this to a file in case we need to do some other analysis. All right. So until this point, from the code repository, we are able to find all the function names, the definitions, the file path, and we have also computed their embeddings and created a new column in the data frame. Now, what we are going to do is we take this natural language query, we compute embeddings for the query, and then we measure the similarity angle between the query embeddings and each of these embeddings, right? And we store that similarity value, which we can call score, as a new column. Okay. And then we will sort this data frame in the descending order so that the records at the top will have the highest similarity. Okay. So we are doing sort of semantic similarity search. Okay. So let's do that. So here we are importing this cosine similarity function. Now this function takes this data frame as input and also the code query, which is this, which in this case here it's completions, API tests, or it can be fine tuning, input data, validation logic, etc. Right? And don't worry about this. This one just says how many functions we want it to return, the top n functions, and we want to print some information or not. And from each function, how many lines we want to show it on the console, right? Some functions might have 1,000 lines, right? We don't want to show all 1,000 lines on this console, right? So by default, we are saying print only first seven lines of the code. So we took the code query and we again computed the embeddings using the same model. Okay, so here we have query embeddings. Now we are creating a new column called similarities, right? We are again using the lambda function, the same concept, but this time we are using code embeddings, right? So we are going over these records one by one. For each record, we are taking the code embeddings and the query embeddings. We are computing the cosine similarity, right? So the query embeddings will be fixed for a given query, right? So we have this vector and we have query vector. We are simply computing the similarity and then putting the value here. And then we are taking this vector and query vector, computing the similarity score and placing the value here. Like that, we are creating a new column with the similarity scores. Okay. So that's what we have done here. And then we can simply sort this data frame using the similarity scores in descending order. So we want the highest value at the top, right? And also we have this optional argument, which is how many functions we want, right? So we are just filtering the data frame to have that head top in values. Now, if we enable the print, what it going to do is, so this res it's a filtered data frame, right? So we are going over the rows one by one. And from each row, we know we already have the file path, the function name, the actual code itself, right? So for the top three records, for example, let's say this, and this happen to be our top three records for a given query. So we take this function definition, and then let's look at this line. So this n lines, which by default is 7, right? So we are printing the top n lines of that function. Okay, that's what we are doing. And before that, we are also printing the file path and the function name along with the similarity score. Okay, so when we call this search function with our original data frame, which contain these 4 columns, and then search query, what it returns is, first it returns the path, which is the path, and then the function name. The function name is test completions, and finally the similarity score. So the higher the similarity score, the more confident we are, right? The score will be between 0 to 1. So the score is 0.82, that's reasonably high. And then when we call this function, we supplied n is equal to 3, meaning we want the top 3 functions which are semantically similar to this one, right? At least the embeddings are semantically similar. So that's number 1, and it has printed these top 3 lines. 3 or 7 lines. How many lines are we printing? We are printing n lines 7. So 1, 2, 3. So probably we have 4. Here we have 4 empty lines. Okay. And then, so this is our second function. All right. And then this is our third function. If you see the scores, so 0.826, 0.81, 0.80. So all these 3 functions have reasonably high score. And from the code, we can see these are completion APIs. So we can see this is a completion API, completion create. This is also completion create, and this one is also completion create, right? So we have got 3 functions which are actually doing what we have described in the query. Okay. And similarly, let's look at this one. So this time we are fine tuning input data validation logic. So remember, we have total 108 functions. So from those 108 functions, we found out the top 3 functions which are doing what we described here. And if you look at this one, so this function definition is format inferer validator, but fine tuning. So it probably coming from this fine tuning. So again, it's not this keyword search, one-to-one keyword search. It's this similarity search using the embeddings, right? So this function, as this comment says, as the doc string says, it seems like it is doing fine tuning and get validators. I'm not sure if it is doing the fine tuning. Now again, notice that for a given description, we might have only one function, or we might not have any function which is actually doing our description, right? So in such a case, it will still return 3 results because we are asking for top 3 records, but those top 3 records may not have the high score. Okay. Necessary additional column vector get validator. Yeah. And infer task type. So infer task type, infer the likely fine tuning task type from the data. Okay. So this function also seems to be doing some fine tuning and data validation steps. Okay. Find common suffix. Maybe let's look at this one. Command line interface for fine tuning. Okay. Here, this time we are asking only for the top 1 function, and also we are asking it to print the top 20 lines. So as you can see here, for this function, it has printed a top 20 lines as opposed to the default some 7 lines. Okay. So command line interface for fine tuning. Okay. Definition tools register, convenience client code, add sub process. Yeah, this should be the local file path. Okay. So Again, as I mentioned, we might not have any function which is actually doing this task, right? So if you look a bit more deeper into the code, this function probably doing that command line interface for fine tuning the models, etc. I'll quickly summarize what we did. We have a repository with all the Python functions, and each Python files, and each file may have multiple Python functions, right? And we may have multiple files as well. So in this given repository, we have 57 files with 108 lines. Now in step number 1, we did some Python processing, text processing, and built these 3 columns, right? And then we have computed the embeddings using OpenAI. That's step number 2. And finally, in step number 3, we have a query. We have used the same model which is used to create these embeddings to create the query embeddings. And then we have computed the cosine similarity between the query embeddings against each record embeddings. And then we sort the data frame to find out the top n records which have the highest cosine similarity. Okay. I find it quite interesting and fascinating. I hope you too. You see, we can search the code using natural language as opposed to the keyword search or pattern matching search we often do using tools like grep, etc. That's all for this video. Thank you very much.